Hello, and welcome to our second marine industry podcast in our Marine STS Industry Series. I'm your moderator, Blake Snodgrass, a writer for the thought leadership team at Siemens, and I'm again joined by our special guests and industry experts, Jan Venos, Vice President of the Marine Industry at Siemens Digital Industries Software, and Dan Radosavljevic, Director of the Marine Industry at the Simulation and Test segment of Siemens Digital Industries Software. So welcome to you both, and it's great to have you here again. When we left off in our previous episode, we were talking about the future of ship design. So let's stay in that same vein, and let me ask a question about future engines for ships, or what future fuel delivery systems do you see coming to the fore in the near future?
Yeah, let's say if you look at fuels, and that's an interesting question, because if you have to go to net zero, that means that you need to have some kind of fuel which is not causing any CO2 or any other greenhouse gases. So then you are thinking about hydrogen. But okay, hydrogen has to be made in sufficient amounts. You can make it with green energy coming from windmills or solar panels. But there are also other fuels which are maybe a little bit cheaper at the moment and easier to get than hydrogen. Hydrogen is not produced in big amounts yet, and the shipbuilding or the ship operation is requiring quite some tons of fuel every year. But if you look at the fuels, then I think in the end hydrogen is a very good one. But also methanol can be used, and then especially green methanol. Ammonia is being used. You see some owners looking at ammonia, but it's also dangerous, and it has to be produced also in a green way. For the smaller ships, say more the inland ships and also the coastal vessels, electrical, but to carry enough capacity on board is limited, so that will only be usable for ships which are sailing on a regular route, not too far away from the coast, and where they can reload every day at least. LNG as a transition fuel. And the other thing what is happening at the moment is to go to cleaner fuels, to get rid of the heavy fuel, go more to sulfur, low sulfur fuels, go more to gas oil. So you have several steps, but in the end, you are looking to the ultimate goal about having net zero fuels, and that's quite challenging to get that on board the vessel. Let's say gas oil or heavy oil has a high density of energy, and if you go to LNG, you already need 3 to 4 times the volume to get the amount of fuel with you to have a range which you need for your operations. So there are some fuels which are being looked at the moment. If you look at new ships being built, then methanol at the moment is the most popular one, especially container companies are ordering methanol vessels and LNG. But we will see what's coming out in the coming years. But it means that there will be a high development in fuels, but also in let's say in the engines, which can burn those fuels, and also with the systems surrounding those engines on board the vessels. And one thing for sure, it will not as easy as having just a diesel engine on board anymore. It will be more complex. So there's going to a lot to be happen the coming years in fuels, and there is not one fuel set at the moment in which direction it's going completely. So they are looking at the options still and choosing what will be the best. So I think from my perspective, hydrogen will be the best, but it's also the most complicated and the most expensive at the moment.
Go ahead, Dayan.
Yes, and I just wanted to say it's interesting that clearly the challenge has increased since this change in IMO targets, to the point that recently there were announcements of 2 classification society doing feasibility studies of nuclear option. And of course, nuclear is like zero carbon emission, but of course there are other implications in terms of safety. But nothing is off the table at the moment with such a big, massive challenge to meet now these new targets. Everything is being looked at.
Yeah, and I agree with you. You're completely right with nuclear, which is an option for certain ship types where there is enough space and where we can let's say safeguard the fact that you have a nuclear reactor on board. But that's also the most difficult one because of liability and international law. But it's certainly an option. And if you see what companies are investing in having, let's say, more commercial operated nuclear small power plants, this could be certainly an option for the bigger vessels. So what Diana is saying, nothing is off the table at the moment. And we will see the coming years in which direction it is going. But it's challenging, but also interesting what's going to happen in the next years.
Yeah, as you said, there are a lot of options there. It'll be interesting to see how that plays out. You both touched on simulation earlier. Let's talk about how the marine industry is using integrated simulation to meet some of their IMO goals.
Yeah, I think this is a question for you, Dejan, as the expert in simulation.
Yes, well, in addition to these changes about the targets for reaching net zero, which impact the design of the ships currently in the design process and the future design, which is addressed through the EEDI index or energy efficiency design index. There is also the question of what happens with the ships currently operation, because earlier this year there was another regulation put in place from 1st of January, which impacts another index, which is called EEXI, or energy efficiency for existing ships. And that also sets now targets for ships currently in operation in terms of how much emissions and CO2 they are allowed to emit. And of course, that is another massive headache for ship owners, because they have to assess whether their ships currently in the fleet, some of which can be fairly young, could be only 5 years, whether they are capable of meeting these new regulatory targets, and then if not, what to do, whether they should just scrap them or whether it's worth investing in modifying them to meet those requirements. And this is really where there is no alternative, in my opinion, to having integrated simulation environment, because you can take the existing ship as it is, put it in a simulation environment, and then run various scenarios, from changing the propulsion system, from changing the fuel, from doing retrofits, from adding energy saving devices, and then go through tens, hundreds, or even thousands of different scenarios and try to figure out, is there a scenario which is cost effective, which makes sense commercially to invest and make sure that the ship has its future, or whether it's just too expensive, in which case the decision may be to decide and scrap the ship. But in my opinion, there is absolutely no alternative for that aspect of the current market to actually using digitalization and simulation to get to the answer.
So can you design out failures in the integrated simulation process in addressing any kind of failures when designing ships?
So failures can come in two different ways. One is when you encounter failures during operation, and then definitely you can look at the root cause of failure and find out the way to mitigate that. Or even at the early design phase, if you are careful with setting the use cases of scenarios that you are simulating your ship, planning the operational envelope it's going to operate in, then again, simulation can pinpoint any potential dangers and any potential failures. In terms of vessels, the most common one come with the propulsion system, whether it's down to vibration, cavitation, erosion, pressure pulses, and so on. And all these can be predicted now accurately early in the design stage and designed out. When it comes to existing ships, looking at energy saving devices there are many common energy saving devices that could be added to vessel to increase its efficiency, such as pre-swirl stators or fins or propeller boss cap fins. But the problem is once you add them to existing vessel, you change the flow, and that may result in some kind of failure. So added, again, vibration or cavitation erosion. And all these things can be predicted and simulated before they're implemented. And that's part of this analysis, as I said, for EEXI, what options a ship owner has at its disposal in order to meet the new regulatory requirements.
Okay, Jan, I think you already covered some of this on retrofitting existing ships, but if we could maybe dive a little deeper into it in looking at cost analysis and new regulations when you're looking at ships that are 12 to 15 years old and being scrapped due to fuel and other traits. What is some of the process involved in retrofitting for new regulations?
Well, I mean, if you look at the range of options that are available at disposal, so wind assisted propulsion, for example, you can put wing sails or flattener rotors or kites. So the question is, all those things cost money. So what will be the outcome of fitting those in terms of operational cost and also in terms of investment cost? The only way to do a proper cost analysis is to do a full ship as a system simulation with the changes that are potentially proposed. Look at the cost of that, look at the cost of at the operational cost, the resulting operational cost over the planned ship life, whether it's another 5 years or 10 years, 15 years, and then make a decision. And as I mentioned, I don't see there is an alternative method that will allow ship owners better way of being able to make a decision. What makes sense, what doesn't make sense, where to invest, and which investment options to stay away from. Because there are so many currently options. Air lubrication is another one. And, it's like ship owners are faced with this huge range of things which are being offered as a solution and not knowing which one actually makes sense. And with simulation, they can get the answer they need to make a final decision.
Thank you for that answer, Jan, and I want to thank both Jan and Jan for their input today in this episode, and we look forward to more on this same topic as we continue the Marine STS podcast series. So we hope you can join us again. Bye for now. Thank you.